Whenever you're wanting to be able to complete a geometric proof, it's often important to begin with an introduction by working with properties, but also some other relationships now, like definitions and theorems. With algebraic proofs, you only have properties to be concerned about, but we have some additional things now with geometric proofs. So I've tried to include a good assortment of those here. In the first problem, we're going to be naming the property or definition or theorem that justifies each statement. And we can build off of what we know about algebraic proofs in order to help us here. The symmetric property allows you to switch sides of an equation and rewrite it with the second thing first instead. That's true with congruence as well. So right here we have these things switching sides. So this is the symmetric property, but this time it is congruence. And I'll abbreviate it like that. Part B, we've got a first thing congruent to a second thing, and a second thing congruent to a third thing. And then the conclusion of that is that the first must be congruent to the third. And that means that we have basically bridged over the middle item and connected the first and the last. Trans means to cross or to cross over. So this is an example of the transitive property of congruence. It allows you to link the first and the last item in a series. Part C, this is actually just like part A. We're switching the sides, but it is equal this time. So even though it's symmetric, it is a property of equality, not congruence. In part D, we have the measure of angle 3 in each one, and then over here that has gone away. So we must have subtracted the measure of angle 3 from both sides, and they were equal when we started, and they're still equal. So this is the subtraction property of equality, and I'll abbreviate it in that way. Part E, we have the use now of a definition. If angle 1 and angle 2 are a linear pair, then angle 1 is supplementary to angle 2. And the reason we can say that is that's part of the definition of a linear pair. And you might abbreviate that in various ways, but I wrote it all out there. But I may abbreviate it when I get further down or in some other examples. Number 2 says use the given relationship or property to complete each statement. So it's the same information, but we're looking at it from a different vantage point. We're given the property and we're completing the statement, whereas up here the statement was completed and we had to name the property. Well, symmetric we know means you can switch the two sides. So AB, segment AB is congruent to segment CD. We switch it around. Segment CD must be congruent to segment AB. Part B, the distributive property. This says that you're going to multiply a group of items by something on the outside of that group. So 16 will multiply by x, which is what is already given here, plus is already included, and then 16 times 2. And since we're multiplying times a number, you could give the result, or I think it would also be acceptable to have 16 times 2 in the blank. It's not really clear what has happened right here, whether these are two separate things or lumped together, but I'd say either one would be acceptable here. The definition of congruence says that if things have equal size, they're congruent, or the other way around, if they're congruent, they'll have equal size. And here it's stated that they have equal size, so we could say that the objects themselves, the angles, are congruent. The vertical angles theorem states that vertical angles are going to be congruent. So if angle 3 and 4 are vertical, then angle 3 must be congruent to angle 4. And finally, we have a definition here at the end, a definition of supplementary angles. Well, supplementary angles always add to 180 degrees. So if if angle 5 and angle 6 are supplementary, then the measure of angle 5 plus the measure of angle 6 must equal 180 degrees.